All right, it's 2 hours UTC once again, and we're here for Astronomy Daily Live. So welcome everybody. Come on in, join the crowd, the ever-growing crowd. I'm just making sure that I've got everything checked out here that I do. I think I tweeted, I think I Discorded, I think I did everything that I was supposed to do. I think so. All right, cool. All right. So yeah, come on in, friends. We're gonna spend the next hour or so thinking and talking astronomical things, and I'm seeing some people getting into the chat. Todd Larson, hey there. Akta, hey. And in the panel, Bobby, hey there, Bobby.
Hey, what's up, guys?
Uncle Bill's in the panel too. Hey.
Hello, y'all.
We just had a fantastic sunset here. I was this close to being like, man, I really need to live stream outside because it's sorta, it's not quite turning fall here yet, but fall is starting to come into the air. Just a little hint, and you know, I like everything about this place. I like all the seasons, but fall is just a little nicer than all the other ones because it's just, the colors of the sky are just amazing. Tonight there were just, and there are just these clouds around with some nice like just perfect blue sky, and the colors of the sunset, just absolutely amazing. So yeah, I was this close, but it's like, I haven't, I've got a couple options, right, to live stream when I'm outside. One of the ways is to pull out the old laptop and try to do it that way, or just use my smartphone. If I use my smartphone, though, I can't share my screen, right? And a lot of what this live stream is about is, sharing stuff. So yeah, I'm kind of limited there. There's gotta be a way, maybe, to figure out how to make the smartphone a little bit more versatile. Because if I could, work out a way to share my screen on the smartphone, then I would probably do a lot more outdoor things. But yeah, so be it. So come on in, everybody. We're going to talk astronomy for the next hour or so. Just sharing a passion, right? That's all. That's all that I'm trying to do here. Not necessarily trying, to teach anything or communicate anything. Just, I've loved astronomy my entire life, as long as I can remember, and I definitely do like to share it. And this kind of platform is fantastic, right? Because it's worldwide. It's absolutely fantastic. We had a fellow on yesterday from Iceland, right? And that's just absolutely fantastic. I think I've got a couple of folks who come in here from like Australia, England. So yeah, it's really cool that, we can come together in sort of a circle of friends. We can get out onto the virtual porch and sit back with our favorite consumable of choice, and turn off the TV, forget about the news, and just think about telescopes and galaxies and binary stars and nebulae and radio waves and X-rays and cosmic rays and mirrors and planets and moons, and it just goes on and on and on and on and on, right? That's what um, uh, drew me to astronomy as a really young kid. Is that no, I didn't really consciously think things like, well, I'm interested in everything, so what should I do? It's just I was just naturally just sort of awed and just blown away by everything, and uh, the science of astronomy seemed to allow me to explore that to its fullest extent. There you know, inside of astronomy, there are a lot of specialties. Sort of, the umbrella, right, encompasses lots and lots and lots of things, and so it's like, hey, that that is it, and that that passion and that curiosity and awe and um, you know uh, just has grown and grown and grown and grown and grown, and you know um, just continues to get more and more and more. So hey there, Space TV, nice to see you there. Haven't seen you here in a while, so nice to see you there. Glad you could come by.
What's also very great about getting international viewers
What's
is
that?
if you really got a world map and some thumbtacks, you can actually pinpoint them of how many interactors would don't mind coming to your channel and to your live stream and interact with you and stuff. I think you
Yeah,
would have like a series of thumbtacks.
yeah, very cool. That's a good idea. I could probably create like a Google map that would do that exact thing.
You could, Anna, Sand Experiment on Twitch, she runs such a map.
Oh, cool. Okay.
And yeah, we've got, everybody gets the pin on there along with the screen names show up. And of course, you can be as vague as you want to be as to where you put your pin on the map. But it's really cool to be able to see just how widespread the sand tribe is.
Sweet. I might have to do that for the lettuce bin then. So yeah.
Yep.
Yeah. Okay. I'll have to I'll have to figure that out because I think that's a good idea. There was somebody else who I forget who it is. She's also a Twitch streamer. She puts the names of her viewers on some kind of background corkboard or something like that. I forget exactly what it is. Is it like? I don't think it's like Rocket Sage. I don't remember exactly who that is, but yeah, to create a Google map that shows the locations of all these would be yeah, I think that'd be really cool. So yeah, that's something to think about. I think I'll try to do that. So cheers to the world.
Yeah, there's a lot of things like that you can do. Coco DeLauder, she's a psychologist. She puts the names of subscribers onto little pieces of paper and puts them inside of this teddy bear that she hugs. So all our subscribers get hugged. Another guy that builds a lot of Raspberry Pi and Arduino stuff just spent months building a burn the subs rig, which is a big laser cutter board on his wall, and subs get laser cut into the board hanging on his wall.
Wow. Yeah.
And that's completely automated. He spent months building that rig.
Yeah. Very interesting. Very interesting. So you know what I'm probably going to have to do. I'm going to have to come up with something maybe original like that.
Yeah.
Yeah, as opposed to something sort of, generic. Maybe I can start, with something generic, to get it going. But yeah, maybe think of something original. I mean, well, as you can sort of see, I don't really have a lot of wall space, but yeah, I don't know. Maybe something can be done. Maybe something can. Yeah, I don't know. I'm gonna have to think about that a little bit. That's a good idea, though. Yeah.
Hey, what's up, Patrick Manning?
Patrick is in the chat as well. All right. Cool. Yeah. Yeah. Fraser was on. He was on. Was it last night or the night before?
It was last night.
Oh man. Man, I must be getting really old because, yeah, that seemed like a couple days ago. I don't know.
Check out the water comment.
Yeah, I just noticed that, and I was interested. Yeah, I actually wanted to talk about that, and I think what I want to do is I want to look at that paper a little bit more, um, and then go through it, like either tomorrow or maybe the next day. I had no idea that things were that developed. But there's the spacecraft. It's called DART, and I actually posted a link to I think to their website, and then they published a paper back in 2017, I think, sort of describing.
Jim Caplet is in the chat.
I see that. Hey there, Crystal. Hey. So yeah, they, as I said, I didn't know that this was as developed. Well, that developed, but they have plans. They've actually got approval now from NASA to go ahead with this project to send. It's probably a couple of spacecraft. One spacecraft is going to smash into an asteroid. They're going to be going to a binary asteroid, right? A big one and a small one, right? They're sort of going around each other, and they're going to smash into the small one, and then watch, see what happens to how it changes the orbit, to see, if we can actually deflect an asteroid. So yeah, I didn't know that it was that developed, but they're planning to launch in 2021 and actually do the impact in 2022. So that's just a couple of years away, right? So pretty impressive. But yeah, I sort of want to look at the paper first, and then go through it in a little bit more detail, because the paper, it goes through a model and all that. And yeah, I just wanted to understand it a little bit more, before I went through it here. So maybe tomorrow, maybe the next day, I think I definitely want to talk about that, because it. Look, there are many asteroids and many comets that have our name on it, right? I mean, it's not a matter of if, it's a matter of when. And it just so happens that we haven't been hit by any large ones, because as you increase the size of asteroids, there become fewer and fewer, right? So, once you get really, really big, large enough to actually, have, create some kind of major disaster here, it's got to be pretty big, right? So those are pretty rare, and so luckily, I guess you'd call it that. We haven't been smashed one of those. But we have been hit actually recently by some relatively large objects, right? And it's caused damage. There is a 70% chance that these objects are going to hit water, right? They're going to hit one of the oceans, which is sort of a problem also, right? I mean, if it's a big one, right? I mean, it's going to cause a tsunami, and it's going to be a mess. But anyway, detecting all these things is sort of the first step, right? You have to find them. Then you have to determine their orbits. That takes time, right? That can take 6 months or a year. Maybe not that long, but the longer you take, the better you can determine the orbit, right? So, so once you determine the orbit, you can sort of project forward and say, okay, is this thing going to hit us? And if so, when? And if the orbit is really, really good, you can actually even tell where, right? Where it's going to hit on the Earth.
I like the way how out of water says enough, and the thought of an asteroid hit scares a lot more than the Russians or who the president is having sex with.
Well,
Trump's fake news.
I don't think fear is the right approach. Because whatever is going to happen is going to happen, and but if we actually determine, right, that a big chunk is going to hit us, well, if we have enough time, maybe we can do something about it, right? And one of the ideas, right, is to change the orbit a little bit, right? You just have to change it a little tiny bit. It's all it has to do is miss, right? It doesn't have to be far away. It just has to miss. So as long as that's going on, that's great. So these guys have developed this spacecraft called DART, and that stands for something. And this is sort of an experiment to see if we could give these asteroids a little nudge, right? And how much of a nudge is it going to be? What does it do after it's gotten the nudge? The whole thing. So yeah, it's pretty exciting, and I think we can do it as long as we have enough time. No problem at all. Remember.
Now,
go ahead,
have you ever seen Futurama?
I know of it. I've never really watched it. No.
Now, there was an episode of Futurama they were showing the bomb shelters at the underground, old New York City, and they say, like, man, you build so many of those bomb shelters, and it was...
Huh. Interesting. Yeah, actually comes to mind to me is Star Trek, the original series. There's one of the episodes where there actually is an asteroid that's going to hit a planet, right? And Kirk goes down. I forget exactly, but he finds this thing that looks like a pylon, right? But there's no way in, right? There's no way in. So they're just sort of like, okay, well, don't know what this is, but their job is to try to divert the asteroid because it's going to hit this planet, and there's some kind of primitive civilization on there, right? Well, he pulls up his communicator and says, Kirk Enterprise, right? And a door opens, and he falls into this thing, right? And he gets zapped, right, somehow, forgets everything, right? Comes to, and the natives find him, and they think he's a god, right? Well, he doesn't know, right? You know, he's forgotten everything, right? So I don't know how long the timeline is, but it's like months and months and months, right? I mean, he's um, and so yeah, you know, um, short story is that pylon is actually a deflector mechanism that um, wasn't working, right? But of course, Spock, he figures out that the language is sort of like a musical language, if I remember right, and he's able to decipher it, and you know, he fixes it just in the nick of time. It shoots up this beam that diverts the asteroid, and you know, all's well, right? And Kirk somehow, I forget exactly, but he remembers after a while. I don't remember how that goes now, but yeah. Anyway, I'm seeing Jandra is in the chat. Hey there, nice to see you
Yes,
there.
Jandra is a friend of mine from Discord and Twitch. Cosmic, you call me the ninja. If I'm the ninja, Jandra Lone is Yoda.
Oh, okay. All right.
Okay, Jandra Lone. Okay, I guess that's Jandra Eloon. I'm not sure how it's pronounced.
Yeah.
Is pro scout for the whole EDU community.
Fantastic. Well, I'm in very good company tonight then. So cool.
Yeah. Now they can wait behind the chat too.
I am watching it as I speak. It's right there. I've got it. So I just sort of like to let the chat go, right? You know, you guys can have you know, conversations. I don't really have to be a part of that. I like to see what's going on. I like to participate a little bit, but yeah, feel free to chat away. So what I thought I would do today, it being the first couple days of the month, actually UT time, right? It's the 2nd of September 2018, but on this day of the month, I like to go over to Cloudy Nights and over to Cal Sky and actually see what's going to be going on for the next month in terms of events, all things astronomical. So let's do that. And I've actually decided to look at both because, you know, and this is the scientist, right, coming out in me. I like to compare, right? I like to see if Cloudy Nights says exactly the same thing as Cow Sky, and it turns out that they don't. You know, they're relatively close, right? But I'll sort of point out a couple of things, and we'll look. You know, this is I think this is good science, right? You know, to sort of look at several examples, and you know, I sort of wonder. It's like, you know, why are there differences? What's going on there, right? Why? You know, we'll see here that you know, Cloudy Nights says, you know, that this event occurs on this date at this time, and Cow Sky says, you know, this event occurs at a different time, and you know, but let's get into this because it allows us to really think astronomical thoughts for quite a while. So I'm going to share my screen.
And if you're going to do that, I might as well start up Stellarium and see if it agrees.
Cool. Yes. Oh, right before I do that, I just wanted to show off a little bit of my data that I took the other night of NGC 7243. So this is a photometry and astrometry project that I'm doing, and I finally got around to stacking all of the data that I took. So this is about 150 2-second long exposures stacked, and as you can see, I'm sort of seeing the same things that I always am. These little streaks here, I think, are caused by the shutter of the CCD camera, and that's an artifact that I'm definitely going to have to deal with, right? It's not a major thing. I've got this seriously stretched, right? I mean, I'm looking at extremely low levels here, but I think let me.
Now, what are the benefits of using a CCTV camera than using your Logitech?
The primary one is that the CCD camera is much more sensitive, and it's also in terms of dynamic range, it's much higher. So it's at least at this point, it's more of a scientific camera. The webcam is what's called a CMOS camera, and it's not quite as sensitive. It's a lot noisier, and it doesn't have the dynamic range that this thing has. So that can be used for science, but it's just not as good as this guy. So I'm actually seeing so I plotted this, and I did that twice, and I actually plotted the same field of view from Gaia. Now you sort of have to translate in your head here a little bit, because so if you sort of see this triangle here, and this guy's a binary, right? So this triangle with a binary is this triangle with a binary, you see? And then if you sort of, this triangle points up to this triangle. I see triangles in the sky. That's just me, right? I just see triangles everywhere. But
how old is your CMOS camera?
How what?
How old is your CMOS camera?
The webcam that I use for like live streams, that's a Logitech C525. So
no, I'm talking about your CCTV camera that you use to capture that.
Oh, this camera is actually pretty old. It's a S-Big ST7ME, and it is definitely on the older side of CCD cameras these days. But
that's the one with the parallel port, right?
That's the one with the parallel port, yeah. and so that sort of shows its age, right?
I'd like to know, like, how much is for new those cameras? How much of those cameras brand spanking new are?
It varies. You can get them. I mean, a good one that and I'd have to do a little bit of shopping around, but a good one you can get for, I don't know, a couple of $1,000 or so. But they go all the way up, to tens of thousands of dollars, right? So, anyway, just to show you here. Oh yeah, yeah. Well, you know, they're nice cameras. So this guy sort of points to this triangle here, and as you can see, this guy points over here. So this guy is sort of flipped 90 degrees. Yeah, but all the stars I'm showing here are down to 17th magnitude, right? So these smallest little dots here are 17th magnitude stars, and you can actually see them all here too. So let me just
John
try.
Elaine said exposure C is something that astronomers look at. Longer the exposure, the less fuzzy the image will get. This is needed to get around distortion caused by the Earth's atmosphere. Normal webcams do not have control over that.
Yeah, to a certain extent, I would agree. I've got a little bit of control with my webcam in terms of exposure time, which is just frame rate, right? It's just frame rate. So I can change the frame rate and actually change the exposure time a little bit. But yeah, CCD cameras in general, yeah, do have a lot more control over that. So yeah, very, very cool. 1 month old. Yeah, and actually, CMOS cameras are, you know, that technology is getting better and better and better, such that they're getting sort of comparable to CCD cameras as well. So it's pretty impressive. But I'm going to stick with the CCD camera for now, just because I've got it. Anyway, so just wanted to give you an update there. I'm seeing, you know, stacked. This accounts for about a 5-minute exposure then, and I'm seeing down, you know, good signal to noise to 17th magnitude, easy. So that's kind of nice. That's kind of nice. So anyway, let's move on to cloudy nights and look and see what's going to be happening in the sky over the next month. So Dave Mitski, he came through again, has provided us with a nice list of events that are going to be taking place in the month of September. And I like the fact that, you know, all the times are in universal time. That's you know, that's sort of a standard astronomical thing. If I need to do the translation, you know, to my local time, that's on me to do that, right? It's not on him to do that. So let's take a look here. So today's the 2nd, so let's just start on the 2nd. Well, and of course, if you haven't looked at Venus towards the west at sunset, you definitely should. And yeah, it's getting really, really, really close to Spica. So nice bright star right next to Venus. The really, really cool thing about looking at a planet right next to a star is that if you look carefully, you'll notice that the star is twinkling and the planet isn't. So that is actually one of the ways that you can sort of tell just by looking whether you're looking at a planet or a star. And the reason for that is that the star is essentially a point source, right? It is so far away. It's so far away that our eyes most definitely, you know, cannot resolve it at all. It is a tiny, 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 tiny point. Sometimes very, very bright, right? But a point. And Venus isn't a point, right? It's actually a disk, sort of an extended source. So you can sort of think of that extended source as a bunch of points right next to one another. Well, each one of those points is actually twinkling, right? But since they're right next to one another, they sort of cancel each other out. And so you don't see a twinkle when you look at a planet, unless you're looking through a lot of air, right? I mean, when you look at Venus, right, really, really low, you will actually notice twinkling because you're looking through a lot of air. But for the most part, you know, planets don't twinkle and stars do. And so, you know, having them that close to one another is sort of an easy way to see that. So let's see. Mercury is at perihelion, which is the closest it's going to get to the sun, this orbit, at 10 hours UTC. So that's in, let's see, it's 2:36 UTC now, right? So that's something like 7.5 hours from now. Mercury is going to be at its closest approach to the sun this time around. And then they're talking about an asteroid, which I'm not quite sure why that's incredibly exciting. I mean, asteroids are cool, I suppose, but I don't know, a 9.9 magnitude asteroid, I don't know. Let's see, the moon. Okay, so it looks like tomorrow, starting actually at 2 hours UTC, for some people on Earth, the moon is actually going to be passing in front of the star Aldebaran, which is let's say that is the brightest star in the constellation of Taurus. So that's looks like yeah. So that's going to be happening at 2 hours UTC. But unless you live in far northern Canada and/or Greenland, you're not going to see it actually pass in front of the star, but it's going to get really, really close. Looks like there's another shadow transit of a couple of Galilean moons of Jupiter. That's always cool. Shadow transits, that is. Of course, the moons transit as well, but the shadows are kind of cool to see. So I guess the Curtis Cross, that's one of those things on the moon that, that you can see if the solar angle is right and all of that. So that's kind of cool. So let's see. On the 5th of September at 8 hours UTC, Venus is going to be as far away from the sun as it's going to get, this time around at least. Aphelion. Mercury is a little bit close to Regulus. That's not incredibly exciting. And again, they're talking about an asteroid at opposition, which, I don't know. Is that interesting? I don't know. I suppose, you know, to some, I suppose it is. Let's see. So, yeah, they're talking about Saturn being stationary in right ascension. That just, you know, because of the relative motions between Saturn and Earth, sometimes, you know, the planets seem to be moving, and sometimes they don't. And sort of, you know, depending on the inclination of their orbits, and or, you know, the positions of the two planets, you know, these motions can zero out. So right ascension, of course, is sort of, you know, east-west motion. So it's probably going to be moving still north and south, but it's not going to be moving towards the east and west. So yeah, just it's just a configuration the Earth and Saturn, we could actually look at a map of the solar system to see what's going on there. Yeah, we don't really have to at this point, but so kind of cool, kind of cool. So at 22:43 on the 6th, the moon is going to be what's called the ascending node. That means that it's going to be crossing the celestial equator, heading north. So that's what that means by the ascending node. It's going to be going north now, and you know, we're probably going to be seeing a descending node 2 weeks after this, right? Because it's got to come back down. Let's see what else is going on here. So the moon is pretty close to the beehive. That's kind of neat. If you do any kind of photography or anything, that's probably a pretty good shot. You know, the beehive is this big, huge cluster of really bright stars in the constellation of Cancer. And yeah, you know, having the moon right there, it's a good photo shot for sure. Very, very pretty. So another Galilean moon shadow transit double at 7:50 on the 7th. So Neptune is at opposition at 18 hours on the 7th. So that means it's exactly on the opposite side of the sun, which also means it's about as close to Earth as it's going to get this year, at least. So that's about as bright as it's going to get, which is actually pretty bright. 7.8. You can see that in a pair of binoculars, right? So if you know where to look with a pair of binoculars, you can actually see the furthest true planet that we have. So yeah, maybe encourage you to see that. You know, you're going to have to wait. You know, because it's at the opposition, right? It's actually rising when the sun sets. So you're going to have to wait, you know, 2 or 3 hours for it to get up. But yeah, you know, might be an interesting view. You know, if you've never seen Neptune before, definitely take a look. It's awesome. It's blue, and you can definitely tell when you look through a telescope, for sure. Right? It's this nice blue disc. So yeah, definitely take a look at that. You know, go to Stellarium or go. I'll bet you Cow Sky might have a map. Let's use this opportunity to go over to Cow Sky and see if Cow Sky mentions this event and what time it is and the apparent size and all that kind of stuff. All that stuff. So let's go over to the calendar. And I was looking at something else before, and I'm gonna see if this does it here. So I'm gonna do the calendar sky for an entire month, right? Select duration 1 month, right? And I'm gonna go to the astronomer level because I can. And I'm going to hit go. And I'm going to look at this really quick because I found something a little funny that maybe only doesn't work with Firefox, but I noticed that maybe it's not going to work here. So I'm going to go all the way to the end of the month, supposedly the end of the month, right? And let's look at the last day. The last day that it says this month is. Look at that. Check it out, right? So I told it to do a month. 1 month. Starting September 1st. Okay? Now 1 month in my book should go to October 1st, right? But cow sky is only going to the 15th of September. So what is up with that?
Possibly too many entries. Yeah, you got a real tiny scroll bar, so
Yeah,
it limited the number of entries for you.
well, that's not very nice. That's not very nice. Okay, well, I mean, I can sort of buy that explanation. I don't like it though, right? I mean, it's like, come on,
Right.
I told it um, to do a month here. Why is Cow Sky thinking for me? Anyway, so let's check this out. So this guy was on September 7th at about 18 hours UTC. So let's go all the way back here. If you all haven't experienced Cow Sky yet, I greatly encourage you to. It is information overload. As you can see, it's just an insane amount of information. Okay, so here's the 8th. So this is the 7th. So all the times here, right? All the times are local time, and they're an hour off, right? Because Cow Sky doesn't keep track of Mountain Standard Time. See, I'm on Mountain Standard Time all the time. I don't change time zones, right? Pretty much everybody else does. But Cow Sky thinks that I'm on Mountain Daylight Time. So it's put all these times an hour ahead of where I actually am, right? So, but let's see. This thing, which is why I just like UT time, right? Now, I think we can probably set that, right? We can probably set that to, I probably have to create some kind of an account. It actually finds me pretty close here, right? But yeah, there might be a setting to do that somewhere. I'm not going to worry about that much. What I wanted to do is I wanted to sort of compare data, right? So this says it's at 18 hours UTC. So for me, I'm 7 hours behind UTC. So that would put me at 11 hours local time. So let's go to about 11 hours. It's probably going to be 12 hours, right? Yeah, there it is. Neptune, opposition, and it says 12. Well, I guess it says 12. I guess that's just a repeat, right? So yeah, it actually says 12 hours, which is actually 11. So they got the time. You know, the time is exactly the same. So let's sort of see if the brightness, 7.8, and this says 7.8, yeah. And the apparent size, 2.4 arc seconds, right? Pretty small. And this says 2.32. So, okay, I'll give him that one, right? That's not too far off. 29 astronomical units away, though. It's just really, really far. So yeah, you know, being that it's that small, right? You're not going to be able to see any kind of disk or anything with a pair of binoculars. But as I said, you know, with a telescope with maybe 100 magnification or so, oh yeah, you will definitely see it. So that's cool. I am glad. I am very, very glad that these two look like they agree. So, because a couple other examples that I saw, let's actually look at this next one here. Okay, Moon is at perigee. that's when the moon is closest to the Earth this time around in its orbit, right? And it says that that happens actually at 1:20 UTC on the 8th. Okay, so that means I've got to subtract 7 hours from that. So that puts me at 18:20 on the 7th, right? Because if I subtract 7 here, I actually go negative, right? So that means it goes into the day before. So moon is at perigee, my local time at 18:20. So if I look on cow sky at 18:20, which is going to be 19:20, right? Well, cow sky says that it happens at 1912, right? 1912. So there's a couple of minutes of discrepancy there, which is not a big deal, but it's a moderately that's quite a bit of a difference there, right?
I'm getting some discrepancies with stellarium too. I think I'm sharing that screen.
Okay, let me.
Neptune. I do get 2.4 degrees for Neptune at that time. But let me zoom out here and you can see it. See this red line here on the right?
Yep.
That is the opposition line. It's not there. Okay? 1400 hours my time. That's UTC -4. That's 1800. It's nowhere near that OC line.
Yeah, interesting.
And Jonah Ewing said having a known object in an image helps determine the distance to an object from the point of reference.
Very, very true. Very, very true. So yeah, there is a discrepancy here, right? Between now there was agreement, between cow sky and cloudy nights in this case. So yeah, Uncle Bill, that's exactly what I was going to suggest. What time does that planet cross that line?
I'm getting there. Let me zoom in for some precision here. And
there we go. Right about there.
Okay, I'm showing 14, almost 1411, plus the 4 hours, that'd be 18. Call it 1810 because I think I hit the button a little bit slow there.
Yeah, okay. So
it's not a huge difference.
Yeah, like 11 minutes.
Yeah.
So yeah, it's just kind of interesting to think about, why, what, I mean, all of these things, right? All three of these things that we're looking at are calculations that are based on models, right?
Right.
And
see, I'm measuring 2.31 arc seconds.
Okay, yeah. That sort of agrees with Cal Sky, I think, pretty well. So cool. Yeah, but since these things are just models that apparently seem to be based on sort of different things, don't know. Now, the one thing that one could do.
Getting a similar error for the new moon coming up too.
Okay. Stick to Neptune for just a second. Why don't you zoom back in a little bit?
Okay.
Because what you can do, right? I mean, if you really want to know, okay, right about there. If you really want to know, right, what you can do is you can take your telescope and like a CCD camera, and you can take a bunch of pictures, right, with Neptune in there and all these stars, right?
Right.
Now, we know the positions of all of these stars extremely accurately, right? So, since we know that, we can actually measure the position of Neptune as well. And in so doing, we could actually measure what the actual time of opposition is with this data, right? And that is not based on any kind of model. That's the actual real deal thing, right? And I'll bet it is different than all three of these. So it's just very, very cool. We do rely on.
Is it the position of the body that were the target body that is in disagreement, or is there a disagreement about what you're calling opposition conjunction line?
Yeah, that's a good question. That's a good question. And
it would matter too, which coordinate system you're using.
Yep.
I'm pretty sure this line that I've got here is based on ecliptic longitude. But if you're looking at equatorial, by descension, you're going to get different figure altogether.
It's very true. Right. Yeah, like I said, it sort of depends on the model that you use. And different models are going to give you slightly different results. So that's why, I always say, this is a pretty good example of, it's like, models are just that, right? I mean, it's a simulation based on guesses and all kinds of parameters, right? And so, yeah, there's a little bit of disagreement there, which is cool. I mean, I don't have a problem with that. I just like to point it out, right? That there's nothing exact. The only exactness, right, is if you actually go out, with a telescope and a camera and actually measure it. Then you'll know for sure, because you're actually observing the actual event, right? So yeah, very, very cool though. All right, I'm gonna keep it going here. Let's see. I've got a kitty on the lap. Oh, he just jumped off. All right. So that was perigee of the moon, closest approach to Earth, and it's kind of neat. The distance between the Earth and the moon is relatively close to the distance between Jupiter and its moon Io, the closest in of the four Galilean moons. So, when you look at Jupiter and Io through a telescope, you can sort of look at that and say, that's how far the Earth and the moon is. It kind of gives you a nice perspective there. And of course, because it's at perigee, being closest, the moon is going to appear larger, or sort of the biggest it's going to appear this time around, at least. So yeah, perigee looks like it happens just a few hours before new moon, which of course is when the moon is between the sun and the Earth. That's very cool. Ah, yes, Jacobini Zinner, for sure. Now this is a really, really cool comet. It's gotten pretty bright. I actually haven't looked at the latest measurements of that, but it was definitely, like 7th magnitude, 7-ish magnitude, at least a couple of days ago. I think Fraser was looking at it too with his scope. So this is definitely a comet to see. It's definitely not incredibly bright, but you know, it's sort of a binocular object. It's definitely a telescope object, but it is going to look like a, you know, sort of a faint little fuzzy thing, and you're going to have to look at it pretty much in the morning sky, right? I think I'm not exactly sure when it rises local time, but I want to say that the right ascension is around like 5 hours or so, which is definitely a morning object. Anyway, it is going to be closest to the sun, perihelion, on the 10th at 7:46. Now let's see what Cow Sky says about that one. I'm always liking to do this. So 7:46 for me is of course 0:46, which this is going to show as 1:46 on the 10th. Yeah, on the 10th. Let's go down to the 10th. We'll get through all this information overload here. Here's the 9th. Was that the 10th? Yeah. Okay, so it's not saying anything about perihelion, or is it? I'm just seeing. I'm wondering why there's 2 entries here. I don't know. Am I seeing perihelion anywhere? Position angle of the dust tail. Not quite sure why there's 2 entries for Jacobi's Zinner right next to one another, coincidentally right near perihelion. But I'm not seeing them mentioning perihelion here. Nope, I'm not seeing it at all. These look pretty much almost exactly the same. There's a couple of differences here. Yeah, I'm not quite sure why there's 2. It doesn't, Cal Sky at least isn't mentioning perihelion at all. Although, you know, I mean, it's getting the distance to the sun correct, right? 1.01 AU, 1.013 AU, so that's about the same. Yeah, not saying anything about perihelion. Definitely, it's worth your while to get up, set your scope up, and take a look at this. This was actually the first comet that I ever saw. I think I was like 11 or 12 at the time, yeah, I mean, it was fantastic. It was absolutely fantastic. So, as I said, you know, it's not going to be incredibly impressive. It's still relatively faint, but if you've never seen a comet before, this will sort of give you a pretty good introduction to what comets look like. And, you know, it's pretty close to the Earth, too. So over the course of, several hours, most definitely one day, you'll notice that it had moved. For sure. I'm going to check the chat really, really quick, see what kind of mayhem is going on here. Oh, not much. Cool, you guys are behaving. I don't know why. I don't know why. What are you doing that for? Okay, let's. I'm sort of noticing the time here, so we may not get through all of this today, but we can pick it up again at some point. Oh, it looks like on the 16th of this month, Mars is at perihelion. So there's lots of perihelions, right? There's Mercury at perihelion on the 2nd. There's, okay, well, Venus is being a contrarian here.
Chandra, Elaine said a strong enough gravity force can allow the viewing of a distant object directly behind the gravity source. Gravity will bend the light around.
That's very, very true. It's got to be a pretty massive object for sure to be able to do that. That's called gravitational lensing, and it's actually a pretty neat effect. Actually, first sort of observed during a solar eclipse of the sun back in, I want to say like the 1920s. It was one of the first proofs of Einstein's general theory of relativity, which predicted lensing around a massive object like the sun. And they actually saw it, and all the numbers worked. So at least according to, matching the data to the model, looks like everything looks good. So, yep, you're exactly right. All right, let's keep going here. So Mars at perihelion, closest to the sun at 13 hours UTC. So that's pretty cool. Let's see, what else do we got here? Yeah. Sunrise on various lunar features, which is always cool. So the moon is at its furthest from the Earth on the 20th at 0:53 hours. So that would actually be, for me, late afternoon on the 19th. That's kind of cool. 21st, Mercury is at superior conjunction with the sun. So that means it's on the opposite side of the sun from the Earth. Mercury and Venus actually go through two different kinds of conjunctions. Inferior conjunction, which is when they are between the Earth and the sun, and then superior conjunction when they're on the other side of the sun. Both seem to, line up with the sun exactly the same. And I'm going to end for tonight with the autumnal equinox, which is one of my favorite events of the entire year. And that happens at 1:54 UTC on the 23rd. So for me, again, local time, that would be 7 hours beforehand. So that actually happens at 9:22 at what, 18:54 local time? Very cool. So equinox, yay! I always like the equinox. Equinox is a special time of year. I always like it. All right, well, we can continue with this later, either tomorrow or the next day or something. We're pretty casual here, so if we're not able to pick it up for a couple days or a couple of weeks, no big deal. But if you haven't been exposed to Cloudy Nights yet, this is just an amazing forum, mainly for the amateur, right? But new people, extremely experienced. This is a very, very, very active website. Extremely active, very friendly, extremely knowledgeable. You'll get, you ask a question here, you're pretty much guaranteed lots of responses, not just one. You'll get a lot of responses, which is good. That's a nice way to learn. Extremely friendly, as I said, extremely knowledgeable. And this guy, Dave Mitski, right? He puts this out every month. And so it's not just events, right? But it's all kinds of other really, really, really cool stuff, in terms of the history of astronomy, different names, dates, all that kind of stuff. And then, he gets into just all kinds of insane detail, right? Which I'm not going to get into here because it's just too much. But it just goes on and on and on, right? I mean, every single planet, right, has a paragraph about what's going on with that planet. And there are actually CalSky links right in there. So very, very cool. CalSky is very, very similar, but sort of as you can see, there's just a lot of details. It's sort of, presented in a different way, right? But if you're a data nerd, like I am, right? I just eat this stuff up, right? I mean, this is great, breakfast, lunch, and dinner stuff for sure. And it just goes on and on and on. Just satellites and planets, what the sun's doing. These first bits here, yeah, I think these are. Okay, yeah, it's just moon passing next to relatively bright stars. Yeah, it just goes on and on and on. All kinds of meteor showers, occultations, just yeah, lots and lots of stuff. So if you like a lot of information, this is the way to go. Now you can tone this down, right? You don't have to be an astronomer, right? You can tone it down. You can be like a learner, right? Or a hobbyist, right? And say that you're doing a hobby level, right? You can do that, and I guess it sort of updates itself on its own if you do that. And you don't get quite as much information, right? You just sort of get what the planets are doing, what the moon's doing, a couple satellites, right? And that might be enough, for you at this point. That's one of the cool things about astronomy too, right? Is that you can sort of, get into this at any level you want, and there's a lot of room, to move around. So yeah, very, very cool. All right, you guys, I'm gonna stop sharing my screen, and I'm going to check the chat really quick, make sure that there is no more mayhem going on. Atta, if you're still there, thanks for coming in. Patrick, very, very cool. It's great to have all of you in. So make sure to share this around. If you haven't already, we're trying to find our crowd here, and this is a worldwide audience. So I think that there is a nice, relatively large group out there. We just have to find them, and I think that is just a matter of time. And as long as I'm here, doing my thing every single day, consistently, I think that will definitely happen. I've already found some fantastic people, just absolutely fantastic. So it can only get better. If this is the kind of crowd that that I've got now, wow, it can only get better and better and better, because these are the kind of people that I want to be around. So All right. Well, very, very cool. Speaking of being around, I'm going to get out of here. So, all right. Take care, everybody. Make sure to subscribe if you haven't already. Smash the thumbs up if you so desire. It looks like that thumbs up thing is working. Our friend from Iceland yesterday mentioned that he had found this channel as a result of getting a suggestion from YouTube, right? And I think that is based on thumbs up kind of thing.
I think it's as much based on your views as your thumbs up.
Is it? Okay. Yeah, I mean, I'm sure.
The only way the algorithm gives you stuff you really want is if you ignore the algorithm. Yeah, if you're a sucker for the clickbait titles that throws at you, then that's all you'll ever get. But if you ignore it for a few weeks and go for the stuff you know you want, then it starts to show you something that you might actually want.
Yeah, cool. And I'm not here to get subscribers and views and anything like that. I just sort of like observing that. The scientist in me is like, that's interesting data, right? So I'm just here sharing a passion, and I think the side effect of that will be growth in terms of subscribers and views and thumbs up and all of that. I'm not in the least worried about that at all. It's just an observation. I think it's kind of interesting, that these things are actually working. So it's very, very cool. All right. With that, I'm going to get out of here. So take care, everybody. I will see you again in a little less. Well, let's see, 22 hours and 43 minutes. 22 hours.
Sounds about right.
43 minutes. I will be right back here. At least it's extremely likely. Extremely likely. Yeah.
All right.
So, all right. Take care, everybody. I will see you on the spin.
Later, nerds.
See you next time. Bye.
Later.